if we think of the trig functions as being defined by a right triangle, then there are actually some hidden relationships between the trig functions just based on the different angles in the right triangle. So for example, in this diagram, let me put the hypotenuse up here. We know that sine of theta is the opposite side, which is y, divided by the hypotenuse. We know that cosine is the adjacent side, which is x, over the hypotenuse. And we know that tangent is the opposite side, which is y, divided by the adjacent side, which is x. All right, fair enough. But in this right triangle, there's another angle other than the right angle. There's another angle up here. Let's call this angle phi, or phi, depending on how you pronounce it. This is a Greek letter, lowercase phi. And relative to phi, all of these trig functions are going to be different ratios. So for phi, sine of phi is, well, it's still opposite over hypotenuse, but the side that's opposite phi is x, not y. So x over hypotenuse. And then cosine of phi is y over the hypotenuse. And tangent of phi is the opposite side, which is x over y. Okay, but since theta and phi are in the same triangle, they aren't completely unrelated. There's a relationship between them. We know that if we add up all of the angles in a triangle, then we get pi radians, right? That's 180 degrees. So theta plus phi plus the right angle, which is pi over 2, has to add up to pi. But this means that theta plus phi has to be pi over 2. But that means that phi is pi over 2 minus theta. Or if you want to work in degrees, which, if you must, I guess it's okay, phi is 90 degrees minus theta. So we can actually take this expression for phi and put it into these trigonometric functions over here. So when we say sine of phi is x over h, another way of saying that is sine of pi over 2 minus theta is x over h. And cosine of pi over 2 minus theta is y over h. And tangent of pi over 2 minus theta is x over y. But if you look at these, right, some of these are actually the same. X over h is actually the same thing that shows up here. And y over h, which is sine of theta, that shows up down here. And x over y, well, it doesn't show up anywhere else, but x over y is cotangent of theta. So we get these three relationships. We find that sine of theta is the same thing as cosine of pi over 2 minus theta. Cosine of theta is sine of pi over 2 minus theta. And tangent of theta is the same thing as cotangent of pi over 2 minus theta. So these relationships are sort of nice relationships, and these are called cofunction identities. And this actually explains part of the names of some of the trig functions. So these are called cofunctions because, right, this angle theta and this angle pi over 2 minus theta, these are complementary angles. Remember, a complementary angle is just a right angle minus the original angle, or two angles that add up to a right angle are complementary angles. So these two angles are complementary angles, and complementary starts with co, and so that's why cosine is the sine of the complementary angle. Sine is also the cofunction for cosine, and here we see that cotangent is the tangent of the complementary angle. So all of the cos in our trig functions are really just sort of a notice or a signpost that it's the original function but applied to a complementary angle. There are actually some more cofunction identities. Secant of theta is cosecant of pi over 2 minus theta. Of course, cosecant theta is secant of pi over 2 minus theta, and cotangent of theta is tangent of pi over 2 minus theta. So you can see replacing any angle with its complement just switches you from a cofunction to its partner. Sometimes these identities can be useful to evaluate trig functions, and in fact you might have already noticed that these patterns show up in our table of nice trig function values. So just as a quick example, if we have an angle theta and sine theta and cosine theta, right, sort of the nice angles in the first quadrant are 0, pi over 6, pi over 4, pi over 3, and pi over 2, right? And for sine, the values are 0, 1/2, root 2 over 2, root 3 over 2, and 1. And for cosine, it's 1, root 3 over 2, root 2 over 2, 1/2, and 0. And in this table, right, the complementary angles go like this. The angle complementary to 0 is pi over 2. And so these cofunction identities say that what's down here for sine should be up here for cosine, and sure enough it is. And what's up here for sine should be down there for cosine, and sure enough it is. Also, pi over 6 and pi over 3 are complementary, so what's here for sine of pi over 6, should be the same as cosine of pi over 3, and yes, it is. And of course, sine of pi over 3, which is root 3 over 2, should be the same as cosine of pi over 6, and yes, that's true. And then finally, pi over 4 is complementary to itself, since pi over 4 plus pi over 4 is pi over 2. And so root 2 over 2 sine of pi over 4, which is root 2 over 2, should be equal to cosine of pi over 4, and it is.